Hello, dear students. Today we will discuss the topic in mobile communication, that is modern wireless communication system. The contents of this chapter are evolution for 2.5G TDMA standards and IMT 2000 project. In that, we will see the different techniques, that is HSCSD, GPRS, H and IS-95B. While in IMT 2000, we will see IMT 2000 vision and evolution aspects and radio spectrum for the IMT 2000. The specific objectives of this study are: student will be able to list out the features of 2.5G GSM standards like HSCSD, GPRS, IS-136, H and IS-95B, and also they will state the features of IMT 2000 radio spectrum, its vision and evolution. The first 2.5G technique, that is HSCSD, stands for high speed circuit switched data. The full form of HSCSD is high speed circuit switched data. It is nothing but the enhancement of circuit switched data standard. The name HS stands for high speed. It is a specification for the data transfer over a GSM networks. Its first attempt to get high speed data over GSM, as it is a circuit switching technology where circuit switched is nothing but constant data rate is achieved. In this technique, the multiple access technique used is TDMA, that is time division multiple access. It offers symmetric or asymmetric data rates. The next features are: it utilizes up to 9.6 kilobyte or 14.4 kilobyte time slots. Its theoretical bandwidth is 115.2 kbps, where 8 into 4 14.4 kbps per time slot is the division. Its practical bandwidth is less than its theoretical bandwidth, that is 57.6 kbps, which is 4 time slots. We can achieve data rate up to 115 kbps with HSCSD. It is limited to 38.4 kbps on 900 MHz GSM networks. It can only achieve 57.6 kbps on 1800 MHz GSM networks. It supports guaranteed quality of service. It bundles up to 8 GSM traffic channels into one high-speed channel. There are some advantages of using these techniques, and these are: lower latency. The second, there is no need for RTS or CTS. It is a better protocol for time sensitive applications such as image or video transfer. It can also take care of error control coding algorithm, and for an application such as downloading, this technique is preferred because in the circuit switched data, which is usually given a priority over a packet switched data on a mobile network, and there are few seconds when no data is being transferred. Apart from the advantages, it suffers from some disadvantages, and these are: it has less bandwidth efficient. We have seen in the features that its practical bandwidth is less than its theoretical bandwidth, which is 57.6 kbps. The second, expensive wireless links than the GPRS. Third, not suitable for the bursty data. It is also not widely implemented, and it is not suitable for the variable data rate applications, as we already defined in the features itself, that it uses a circuit switch techniques, which is nothing but the constant data rate. It only needs the service provider to implement a software changes at existing GSM base stations. Its applications are in the telefax, in the image or video transfer, in the downloading, in the real-time interactive web sessions, and in the dedicated streaming internet access. The next technique of 2.5G GSM is GPRS. GPRS for 2.5G GSM and IS-136, where in this case IS stands for Interim Standards. The full form of GPRS is General Packet Radio Service. As its name consists packet, that means it is a packet based data network. It is the first service which is available to offer full instant wireless access to the web. It supports many users, that is multi-users, than HSCSD, but in the bursty manner which is not possible in the case of HSCSD. It shares the individual radio channels and the time slots. It provides continuous connection to the internet for the mobile phone and computer users. Its transmission rates are 115 kbps to 171 kbps. So we can say that it's a variable data rate is possible with this GPRS, which is not possible in the case of HSCSD. The next features of GPRS are: it provides a packet network on the dedicated GSM or IS-136 radio channels. It retains the original modulation formats specified in the original 2G TDMA standards. It also uses a completely redefined air interface in order to better handle packet data access. When all 8 time slots of a GSM radio channel are dedicated to GPRS, an individual user is able to achieve as much as 170.2 kbps, which is nothing but the 8 time slots into 21.4 kbps of raw uncoded data throughput. This technique was originally designed to provide a packet data overlay which solely for the GSM networks, but at the request of North American IS-136 operators, GPRS was extended to include both the TDMA standards. And that's why in the title itself, its name is GPRS for 2.5G GSM and IS-136. The next, its advantages are: users are always connected and online. This is very important advantages. The second, users will be charged only for the amount of data that is transported. The third, user is able to download much more data than that it uploads on the internet. GPRS subscribers are automatically tuned to the dedicated GPRS radio channels and particular time slots for always on access to the network. For GSM providers, this new technology will increase the data rates of both circuit switching, that is HSCSD, and packet switching, that is GPRS, by a factor of 10 to 15 times. It also provides their own error correction schemes. Apart from the advantages, it has some disadvantages, and these are: data throughput decreases when more users attempt to use the network as it is a multi-user technique. Installation of GPRS requires the GSM operators to install the new routers and internet gateways at the base station and new software that redefines the base station air interface standard for the GPRS channel and time slot. And this is again a expensive system. The applications of GPRS are in the non-real-time internet usage and in the retrieval of email, faxes, and asymmetric web browsing. Now, next technique for the 2.5G GSM and IS-136 is Age, where EDGE, that is Age, stands for Enhanced Data Rates for GSM Evolution, where GSM stands for global system for mobile communication system. H is sometimes referred to as enhanced GPRS or simply eGPRS. Here the word enhanced is used to show that there are some enhanced features included in this technique which are not there in GPRS. It is more advanced upgrade to the GSM standard. It requires the addition of new hardware and software at the existing base station to achieve this enhancement capability. Age introduces a new digital modulation format, that is 8 PSK. PSK stands for phase shift keying, which is used in addition to the GSM standards, that is GMSK modulation, where GMSK stands for Gaussian MSK modulation. Age allows for 9 different, which are autonomously and rapidly selectable air interface formats known as multiple modulation and coding schemes, simply MCS, with varying degrees of error control protection. The next features are where each MCS state may use either GMSK, that is low data rate, or 8 PSK, that is high data rate. So here we need to consider and remember these two different shift keying techniques, that is GMSK and 8 PSK. One is used for the low data rate, another is used for the high data rate modulation for the network access, depending on the instantaneous demands of the network and the operating condition. Because of the higher data rates, which is possible with the 8 PSK, and relaxed error control covering in many of the selectable air interface formats. The coverage range is smaller in H than in the HSCSD or GPRS. So we can say that here the coverage range is smaller in case of H. H uses the higher order 8 PSK modulation and a family of MCS for each GSM radio channel time slot, so that each user connection may adaptively determine the best MCS setting for the particular radio propagation conditions and data access requirements of the user. This adaptive capability to select the best air interface is called incremental redundancy. Here the word incremental redundancy is important. That signifies that adaptive capability to select the best air interface is the property associated with the age, and that is so called incremental redundancy. Due to it, packets are transmitted first with the maximum error protection and maximum data rate throughput, and then subsequent packets are transmitted with the less error protection, usually using punctured convolutional codes, and less throughput until the link has an acceptable outage or delay. There is a rapid feedback between the base station and the subscriber unit. Then it restores the previous acceptable air interface state, which is presumably at an acceptable level but with minimum required coding and minimum bandwidth and power drain. The incremental redundancy maximizes the user capacity on the network by providing acceptable link quality for each user. This is the feature associated with the incremental redundancy. When H uses 8 PSK modulation without any error protection, and all 8 time slots of a GSM radio channel are dedicated to a single user, a raw peak throughput data rate of 547.2 kbps can be provided. By combining the capacity of different radio channels, for example using multi-carrier transmissions, H can provide up to several Mbps of data throughput to the individual data users. The next technique for the 2.5G CDMA is IS-95B. Here, the word IS stands for Interim Standards. The interim, that is meanwhile data solution for CDMA, is IS-95B. It is also known as TIA or EIA 95. Here the word 95 signifies that it was successfully acceptable and established in the year 1995. Combines IS 95A, ANSIJ STD 008 and TSB 74 into a single document. CDMA 1 IS-95B was first deployed in the September 1999 in the Korea and has since been adopted by operators in Japan and Peru. So it has a single upgrade path for eventual 3G operation. It provides high-speed packet and circuit-switched data access on a common CDMA radio channel by dedicating multiple orthogonal user channels, that is Walsh functions for specific users and specific purpose. The original IS-95 throughput rate specification of 9.6 kbps was not implemented in the practice but was improved to the current rate of 14.4 kbps as specified in the IS-95A. The next features of IS-95B are: the IS-95B supports medium data rate, so-called MDR service, by allowing a dedicated user to command up to 8 different user Walsh codes simultaneously and in parallel for an instantaneous throughput of 115.2 kbps per user. Its practical throughput is about 64 kbps, which is available to a single user in the IS-95B due to the slotting techniques of the air interface. This also signifies hard handoff procedures that allow subscriber units to search different radio channels in the network without instruction from the switch, so that subscriber units can rapidly tune to the different base stations to maintain the link quality. Prior to IS-95B, the link quality experienced by each subscriber had to be reported back to the switch through the serving base station several hundreds of times per second, and at the appropriate moment the switch would initiate a soft handoff between the subscriber and the candidate base stations. So from this it is clear that in the IS-95B, medium data rate is used. Its practical throughput is 64 kbps, which is available to the single user, and it uses hard handoff. The next is IMT 2000. Now, up till now, we discussed the various 2.5G techniques. But now, from IMT 2000, we will move towards 3G techniques, where 3G stands for third generation mobile communication techniques. Here, IMT 2000 systems are considerably different from the 2G mobile and PCS. It finds usage in the wide range of services and offer the global mobility. The radio interface or the radio transmission technology, which is deployed in the existing wireless system, requires a change to provide the needed spectrum efficiency and capability. There are various RTT, those who have already been developed around the world. These technologies were submitted to the ITUR for evaluation and final selection of technology by the end of year 1999. Here the 2000 represents its established year, and here ITU stands for International Telecommunication Union. The primary objective of the evaluation is to confirm that all the ITU requirements are fulfilled and select the RTT that can cover all the radio operating environments with most commonality. The evolution includes higher data rate, WCDMA air interface, WCDMA high-speed packet access integration of other wireless technologies such as WLAN, a all IP network evolution. The next is IMT 2000 significance, so-called IMT 2000 importance. The rapidly growing internet environment and the service requirement in the telecommunication. The second, service requires support for asymmetric interactive multimedia traffic based on high-speed packet data transport. It is therefore necessary to recognize international or global standards for the mobile telecommunication to ensure seamless global mobility and service delivery, as well as integrating the wireline and wireless network to provide telecommunication. The next, service transparent to the users. Next, IMT 2000 is that global standard to satisfy the market demand for the mobile services in the MT first 21st century. It is also known as International Mobile Telecommunication 2000, where this International Mobile Telecommunication is the short form of IMT. It is the ITU globally coordinated definition of 3G, covering key issues such as frequency, spectrum use, and technical standards. The next topic is IMT 2000 visions, that is so-called objectives or features. So let's see the important features of IMT 2000 project. The first aim or objective was the first, a worldwide common spectrum which is available in 1.8 to 2.2 gigahertz. The second, it is a global seamless roaming. Third, enhanced security and performance. Next, full integration of wireless, that is satellite, and wireline, that is terrestrial system. It increases the spectrum efficiency by having a flexible radio bearers. It in this the multiple environments not only limited to cellular but includes cordless satellite, LANs, wireless local loops, that is WLL. Wide range of telecommunication services, that is data, voice, multimedia, internet, etc. is possible with this, and data rates for the mega cell are greater than or equal to 9.6 kbps, for macro cell greater than or equal to 144 kbps, for micro cell greater than or equal to 384 kbps, and for indoor environments pico cell up to 2 mbps. So the maximum data rate available and possible with this IMT 2000 project is 2 mbps. The next are the major 3G technologies which are proposed for the IMT 2000, and these are the first, WCDMA, which is backward compatible with GSM, so called UMTS by the ETSI. So UMTS stands for Universal Mobile Telecommunication Service. The IS-95 standard, that is so called CDMA 1, is evolving its own vision of 3G CDMA 2000. So the next 3G standard is CDMA 2000. IS-136 standard is evolving its own migration to 3G, which is Universal Wireless Communication, so called UWC 136 or IS-136HS, where HS stands for high speed. So these are the three techniques of 3G. The first, WCDMA, the second, CDMA 2000, and the third, IS-136 or UWC 136. The radio spectrum which is used for the IMT 2000 is in the year 1992 for IMT 2000, the frequencies bands, that is from 1.885 to 2.025 gigahertz and 2.110 to 2.200 gigahertz were allocated. That is, uplink is from 1.885 to 2.025 gigahertz, which is the mobile satellite services, and for downlink it is 2.110 to 2.200 gigahertz. The terrestrial IMT 2000 networks will work in the following bands. For uplink, it is from 1.920 to 1.980 gigahertz. For downlink, it is 2.110 to 2.170 gigahertz. FDD with the mobile stations transmitting in the lower subband. For uplink, 1.885 to 1.920 gigahertz, and for the downlink it is 1.010 to 2.025 gigahertz unpaired for the TDD operation. In Europe, the TDD band for uplink is from 1885 to 1900 megahertz, not available for license use of the IMT 2000, and this is used by the cordless telephony, so called DCT. So this is the radio spectrum for IMT 2000. Uplink and downlink frequencies are mentioned here. So this is very important to know. With this, we will end this presentation. I request you all kindly go through it. Have a look on each topic on 2.5G and 3G, and thank you so much.